Hello everybody, today we're going to be looking at flame test calculations. Okay, the lab that we did over a week ago now has to get finished. You got to do some calculations, you got to get them done. So I'm going to show you how to get these calculations done in this short video. Okay, so what we got over here is first of all, you have to have your lab. Okay, so your lab should be something like this. At this point, you should have all this materials settled. You should have start written down the color of the flame that you had and the metal that you had. So we're going to pick one of these, and I'm going to go ahead and I'm going to start with this. Let's start with sodium right here in the middle. Okay, so I'm going to take that sodium and we are going to first we're going to figure out what color was produced when we had it. So we said sodium, when we physically lit it up, it turned orange to a yellow color. And so what we want to do is you want to flip back to your page and you want to look. And if you look at this and the wavelengths of color have been expanded here, we can expand this and you can see that what we said was we had some yellow and orange. So we're going to be crossing over in this range. 500, we're looking at 600, so this might be about, I don't know, 580 or so. Moving on into orange, which is the 700, we're looking at about 650. So we want to kind of find out and kind of believe what range we're looking at. So when we looked at sodium, we had a yellow to an orange color that took place. So it's going to be somewhere in here. Now when I noticed it, it was more of a orangey kind of color as opposed to a yellow. So we're going to keep it between these numbers here, between 685 and 650. You and your group have to decide what range you believe it was and come up with a number that is as close as you can. If we wanted to do this the way that you would do it in a lab to find the exact wavelength is we would use a spectrometer, which we don't currently have, so we're going to guesstimate based on our visual observations. So orange to yellow, we're looking at this range, but because we're getting closer to yellow and bright orange is 600, I'm gonna pick 625. That is the piece of information that I'm going to use for my calculation. So on your data table, once you pick that wavelength, you can write that down. So I put my 625 on my data sheet. And now I know where I am going to start from. Okay? So in this calculation, we have delta E, the little triangle, that is delta, that means a change. The E means a change in energy. The H is right down here in orange. It says H is Planck's constant. So the number is 6.626 times 10 to the negative 34 joules times seconds. That's never, ever, ever going to change. That's always going to be the same. The next part, that C, is the same C that we used in E equals mc squared calculations. That's the speed of light. This time they gave it rounded off into the thousands place. We're going to use 3.0 times 10 to the 8th meters per second because that's easier for our purposes. We don't have instrumentation that gets us to the thousands places. The only thing that you are going to need to calculate here is the wavelength of light in meters. What we measured them in was nanometers. So if we look at this, this is nanometers, so we could write nm. We have to convert to meters. So in order to convert nanometers into meters, we are going to need a conversion factor. It just so happens that 1 billion nanometers equals 1 meter. Now that's a hard number to write. It's even hard to fit on this screen. So what we are going to need to do is we're going to need to convert our nanometers into meters, but what we're going to use is scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros present here. So I'm going to write this as 1.0 times 10 to the 9 nanometers equals 1 meter. Now that's a number we can fit into our calculator. From here, we're going to look at that 625 that we calculated, and we're going to convert it into nanometers. So we will take 625 nanometers. We're going to multiply this, and we're going to cross cancel. So if we look at this, this is essentially the same as 625 nanometers over 1. Over here, we're going to look for nanometers, and we're going to put that across so we can cancel that out. So we'll put 1.0 times 10 to the 9 nanometers. On top, we have 1 meter. And now this is a problem that we can solve. And we will solve this using our calculators. So on your calculator, and many of you have these calculator problems, so what we want to do is we want to make sure that you have an opportunity to see the keys. So we're going to take 625 times 1 divided by, when we go down a fraction, we're dividing. When we go across the top or the bottom, we multiply it. When we go down, we divide. So 625 times 1, it's going to be 625 nanometers times meters, complicated unit. But when we go down, that's when this unit goes away and it's divided. So let's see, if we put into our calculator 625 times 1, that's going to be 625. Then we're going to divide it by 1.0 exp 9, that gives us our exponent, and we will hit equals, and that's going to say that my answer is 6.25. I have to put the times 10 back. The calculator takes that out. I have to put it back in. So I'm going to put times 10, and then I have to put the exponent to the negative 7. Now in my answer, I only have one unit that hasn't been crossed out, so I'm going to put meter. This is the last part that we needed in order to be able to calculate, to do our big calculation here. Okay? So now that we have this, we have the 3 pieces that we needed. We have Planck's constant, okay, and Planck's constant is h, 6.626 times 10 to the negative 34 joules times second. C is the speed of light, okay, meters per second, and we have the wavelength of the light in meters. Now that we've converted our nanometers into meters, we're good to go. All we have to do is, let me get a second whiteboard out here so I can do this calculation very easily for you. Now, we're going to take that 6.625 times 10 to the negative 7. Okay, and that was wavelength, so we have that little weird y. Okay, then we have Planck's constant. So 6.626 times 10 to the negative 34 joules times a second. And then we have the speed of light, which we call c, and we got 3.0 times 10 to the 8 meters per second. So again, meters divided by seconds, joules times seconds, and right here, remember our unit that we had left over was meters. So our formula now, we got delta E equals H times C divided by the wavelength. And so what we got to do is we got to put these numbers into it. My apologies. We put these numbers in to this formula. So we don't know what this is. This is what we're going to solve for. I'll box it now. But we do know H is Planck's constant, C is Cp, and we know that our wavelength is here. So we're going to multiply Planck's constant times the speed of light. And we're going to multiply this, so I'll put parentheses, by the speed of light, 3.0 times 10 to the 8th meters per second. And we will divide this whole thing by our number, which is 6.625 times 10 to the negative 7. And we will solve for this. So when we look at this, meters, okay? And what we look at is meters are on top of this fraction bar, and they're on the bottom, so they will go away. We look over here, we have joules. There are joules nowhere else in this problem, but we do have times seconds. We go over the top and then down, that is cross-canceling, so we can cancel out seconds. The only unit that's going to be remaining here is joules. And we're looking for delta E, or the change in energy, and energy is a unit that would be measured in joules. So we're looking solid. Now, you're going to put this number in scientific notation into your calculator, times this, divided by this, and you got your answer. So let's do this together. Let's crunch some numbers. First number to put in is this number. We're going to put 6.626. Times 10, we're not going to put times 10, we're going to hit EXP. We're going to hit the negative key because it switches positives to negative, and then we're going to hit 34. This is done. We're going next to the speed of light, so we're going to say times 3.0 EXP 8. Then we will divide, we'll go down, so we'll say that division, so we're dividing this whole thing by 6.625 EXP, the negative key again, 7 equals, and this gives me a long number, we will round it off to 2 decimal places, so I'm going to say 3.00, this 0 keeps the 0 the same, but we got 2 significant figures here, times 10 to the negative 19, and then we look here and we have joules. So delta E equals 3.0 times 10 to the 19 joules. Ladies and gentlemen, this is all you got to do. When you are finished with this, you write up all your answers. Okay, where is my paper? Okay, you go ahead, we got nanometers after you converted it into meters, and your final answer after you've done your calculation. Answer these questions, and you will be ready to submit your lab on Thursday or Friday. Ladies and gentlemen, that's it. Seems like a lot of work, but it is kind of easy work once you get the hang of it. Do your best. If it's not good enough, come to tutorial and we can fix it. Have a good day. Have a happier holiday.